Hi gents, welcome back. We're gonna do paper 2 from your mocks, so we'll just kick straight into it there. If you want to get it out, there's a chance to just correct it, go over it. So what do we have? We've got a particular property, and we've got a square, rectangle, and parallelogram, and we've got a tick if it is true that it is that it applies to it, and we leave it blank if it doesn't. So does a square have 4 right angle angles? That's what I mean by putting that in there, and of course it does, as does a rectangle. That's literally the name of it. A parallelogram doesn't. Okay, there aren't right angles there, so we would leave that blank. Both pairs of opposite sides are parallel. Well, in a square, the opposite sides, that is parallel to that, that is parallel to that. So yeah. Same is true for a rectangle, and in a parallelogram, that is parallel to that, and that is parallel to that. So it's true for all of them. The diagonals are equal in length. So that line there is equal to that line. That is true for a square. It's also true for a rectangle. That length is equal to that length. All good. But this length there is not the same as that length there. So not true for a parallelogram. The other one has only one pair of parallel opposite sides. So does a rectangle have one pair of opposite sides? No, it has 2. Okay, so that's not true for that one. This one is parallel to that one, but it also has a second one. That's also true for a square. It's got 2 pairs of parallel opposite sides, and same is true for a parallelogram. There are 2 pairs of them as opposed to just one pair, so actually none of them fit that one there. And diagonals bisect each other, so that is to say that is that length and this length is that length. That's true for a rectangle. That is that length and that length is that length, and in fact all 4 are the same in a square, although it didn't ask us that. And it is also true for that. That is that length, and then these are also bisected, not the same as each other, as in the 2 dash is not the same as 1, but each diagonal has been cut in half, okay, compared to itself. So it's also true for a parallelogram. So that's what we have there. That's that one. Okay, that was question 1A. We'll move on to question 1B. Okay, it's just a practical question. We have a particular shape, not quite a right angle, also not quite a right angle, and here we go. Okay, we're told that this is 94, so a little bit bigger than a right angle. We're told that that's 87, a little bit less than a right angle. We're told that this is B, and we're told that that's A, and we're told that this is 58 degrees, B degrees, A degrees. Okay, so in this case, what they're asking us to do is they're just asking us to find out what is A and B. So this is nice and simple. If you really want to show your examiner your work, you can say that this is true because it's a straight angle. So A is equal to 180 minus 58. Subtract 58 from both sides, and that looks to me like A is 122 degrees. So we can fill that in there. And then what we can say is that 87 plus 94 plus 122 plus B is equal to 360. If you've got a quadrilateral, if you've got a 4-sided shape, you're dealing with 360 degrees. So we can just add up everything that's on the left there. 87 plus 94 plus 122 is 303. Plus B is equal to 360, and you just subtract 303 from both sides. So that gives 57 degrees. Nice and simple. Okay, so that's that one. Nothing too tough there, I don't think. Okay, the next one, it's a picture, so you're gonna have to stick with me. It says, question 2, hopefully you have it out in front there. It says the line passes through the points A and B as shown in the diagram. What's A and what's B now? Every single point that you look at should be the X value and the Y value. So how much do you move over on the X? You move over 3. And how much do you move up or down? You move down 0. Okay, that's what A is. Don't get that mixed up. B, how much do you move over? You have to move over 9. How much do you move up? You move up 3. Okay, that's what B is. And it asks you to find the equation of line L. So to get the equation of a line, you need to have a point. And we have 2 of them, in fact. And you need a slope. So there'll be a couple of ways of doing this. If you want to play it really safe, get the formula for slope. It's y2 minus y1 over x2 minus x1. And label them. x1, y1, x2, y2. Actually, y1 over here. Okay, y2, 3, minus y1, 0, over x2, which is 9, minus 3, so we're going to get a slope of 3 over 6, which is known as a half. Okay, that's what the slope is. There would be another way to do it. I mean, if you look visually, like have your exam paper there in front of you, if you look visually, where are we going from? We're going from 3, 0, A to 9, 3. And we've learned that the slope, we write it as m as well, it's equal to rise over run. So if you look from A to B, how much did it rise? How much did it go up by? Well, it had a height of 0 at A and now it has a height of 3, so it's gone up by 3. And how much has it moved over? It went from being at 3 to now being at 9, so it moved over 6. So you can just look at it, and there's definitely value to being able to just look at it and say that that's that. Now, it's a bit risky because if you do make a mistake, you're going to get no marks for it. So using the formula is, I suppose, quite safe. What are we going to do? We're now going to use the formula. This is all in the tables book. Y minus y1 equals m times x minus x1. And you can use any point which is on the line. We'll use 3, 0 because it's a nice number to deal with. We're dealing with a 0 in there, which is handy. And we know that the slope is a half. So we get y minus 0 is equal to m, which is a half, times x minus 3. And you know what? It would actually be fine just to leave it like that. Typically though, what I would do is this. I would write it as a half, and I'd write x minus 3 over 1. I just suggest this for times when it's not so easy. In this case, you know, it's hard. Well, I won't say it's hard to go wrong. I'm sure someone will find a way. But this one would count as straightforward. Okay, but if you write them both as fractions, top by top, bottom by bottom, and now it's clear, multiply both sides by 2. 2y is equal to x minus 3. And you can kind of write this as you want. You can leave it at that, I guess. Typically what I would do is I'd write it as x minus 2y minus 3 equals 0, or 0 equals that thing. That is the equation of line L. So that's question 2b. Okay, the line L is reflected in the x-axis. This is going to be tricky to draw. And does it ask us to do it? Yeah, it asks us to do it. Okay, so I'll just give you a very, very rough idea of what we're doing here. Okay, when it says that it is reflected in the axis, this is what it means, in the x-axis. You take a point, any point, and if it's reflected in the x-axis, it means you head directly to the x-axis. There we go. And you, when I say directly, it's at right angles, and you go back out the same distance and direction. So that would be about there. Let's just take this point here. You would go directly to the x-axis and back out the same distance and direction. Maybe you're there. Okay, take that point directly and the same distance and direction. And what you see is we're just creating the line again. If you think about it, at this exact point here, if you go directly to the x-axis, well, it's on the x-axis, so you're already directly there. So if you go the same distance and direction, well, you haven't moved. So it's just going to be there. So actually, what is this thing going to look like? It is just going to look like, God help my attempt at drawing a straight line, but it looks something like that. Okay, so when something is reflected like that, it's like the x-axis is a fold along a book, and you should be able to fold the crease, and it should overlap with the original thing. So that is what they were looking for there. Oh, and look, they actually asked us to do that. So with B, and I forget what B was. B was 3,9. They ask us to say, put down the image of B. That is to say, where does B go to? There. And actually, I don't even need to have it nicely done out to be able to answer it. Because if you think about it, what do we do? B was 9.3, giving away the fact that the student whose paper I'm looking at managed to mix those up. So that's what I was taking it from. If we have it as 9.3, what does that mean? That means we've moved over 9 and we've gone up 3. So what's going to happen when we go directly through the x-axis? Well, we'll still have moved over 9. And what are we going to do? Well, to get to the x-axis, you have to come down 3, and then to do the same distance and direction, you have to come down 3 again. So it's going to be 9 minus 3. So I don't even have to have that written out nicely in order to be able to do it. Okay. It asks us then to get the area of the triangle BAB. Okay, so might be, oh God. Yeah, this could take a while. Yeah, it's not the worst thing I've ever done. Okay, there's A and BAB. So what are we looking for here? What we're looking for is the area. To get the area of a triangle, it's half the base times the perpendicular height. Take this to be the base. Okay, take that green line there to be the base, because that'll allow us to get the perpendicular height. We know that we just went down 3 and we went down 3 again. So that base is going to be 6. And the perpendicular height from there to there, we already said that that was 9. We've moved over 9. So there you go. So 9 by 6, it's been a while, 54. So half 54, 27. And don't forget to put in units squared. That's important. That's important. Okay, so half of that. Okay, question 3. The graph shows how 2 students spend their pocket money. We actually mentioned this in class. Killian and Sophia there. From the graphs, can you tell which student spends more on movies? So it looks really like, oh yeah, Killian spends more on movies, but all that the diagram tells you is that Killian spends a greater proportion of his money on movies. Okay, so if Killian gets €10, and let's say, I don't know what that would be, is approximately, it looks like €3 on movies based on what it's there. It's a little bit more than a quarter as far as we can tell. Whereas if Sophia has €100 pocket money a day, and if she's spending I don't know, less than a quarter anyway, so we'll just say €20 on movies. Yeah, she's spending a lower proportion. It'll be a lower area segment on her pie chart compared to Killian here, who is spending a greater proportion. But the question was, can you tell which student spends more money on movies? And the answer is you can't, because you aren't told how much it is that they are spending. So, you aren't told what the overall amount is. So in that case, the answer is no, you can't, because you're not told how much money they are being paid, or if they're on the same amount. Any one of those would be a fine explanation for it. Okay, wow, this is going to be a little bit tricky. It says the triangle PQR has has 6 centimeters, 10 centimeters, and that construct the triangle below. Okay, I'm not going to be able to construct the triangle here. That's actually, I will make a separate video with constructions. I know many of you have done tech graphics, and that'll be a doddle to you, but we need to talk about this, and I'm gonna have to have some sort of webcam, something like that, which we will do and get that out. But for the moment, let's just see what the question is. We've got a right angle triangle, PQR, from P to Q to R is 90 degrees. So it says QR is 10 and PQ is 6. And it asks us to find what's PR, that thing there. Can't help but think this looks a lot like Pythagoras' theorem. Now look, they wanted you to measure it using a ruler, that's fine, but then they say, and I can't do that here, but then they say use maths to verify it. So that is Pythagoras' theorem. You have to be able to think that that is what it is. So that is a squared plus b squared equals c squared, where c is the hypotenuse. 6 squared plus 10 squared equals x squared. Just work it out as you go along. 36 plus 100 equals x squared. So x squared is 136. X will just be the square root of that. They only wanted the previous one to one decimal place. So to one decimal place, that will be 11.7 centimeters. Hopefully that's what you got for, is it PR? It was PR. Hopefully that's what you got for PR when you were measuring it and when you did that. Okay. Yeah, we might stop on question 5 there, something like that. Okay, Mel and Danielle are playing a game. They spin the pointer on the spinner. If the pointer lands on an even number, Mel wins. If the pointer lands on an odd number, Danielle wins. Is this a fair game? How do you know? Okay. Well, let's see. So how many ones are there? There are, we might just take the particular number. The number itself and the frequency that it comes up. So 1 comes up twice. Is there 2? Yeah, 2 comes up once. That's nice and confusing. 3 comes up once. 4 comes up 3 times. 5 comes up once, as far as I can see. 6 comes up also once, and 7 comes up once, as far as I can tell also. So 1, 2, 3, 4, 5. There are 10 slots, and I here have 5, 6, 7, 8, 9, 10. 10 counted, so I haven't missed any, so all is good. What does it say? If the pointer lands on an even number or an odd number. So we'll just count the number of evens, and we'll count the number of odds. So we're looking here, how many evens are there in total? There are 5 evens. And how many odds are there in total? It would have been helpful if I used a different thing for the odds, just to see what. We have 2, we also have 5. Okay, well of course we do, it's out of 10. So the chances of an even coming up is 5 out of 10, we should say. Odds of that, 5 out of 10. Odds of an odd coming up is 5 out of 10, or another way to say it is a half. A half. Is it a fair game? Yeah, it's a fair game in that it's 50-50. Okay, this assumes that the spinner is a fair spinner and there's no magnets or anything. You don't have to be a conspiracy theorist while you're doing your junior cert or whatever sort of thing is going to be there. I think we can just take it as face value that it's 50-50, so that it is a fair thing to do. Okay, gents, I think what we will do is we will stop there. I know I've given you time just to do the corrections from paper 1. If you've already done them, please send them on to me, and move on now to doing the doing the corrections for paper 2. Okay, all the best. Take care.